Hi friends, very good evening and thank you for joining in. And I think some of us are a little early today, so feel free to ask me some general Q&A. I'll answer them in the next 10 minutes or so, and then we'll go into the actual live session where we'll solve a bunch of interesting problems in propositional and predicate logic. Okay, so let's get started. Again, can you please confirm if everything is working as expected in the chat window? If I'm audible and visible and things like that. I'm just checking myself on my phone. Things are looking good. No issues that I can see. So if you have any questions about gate prep, I'll be happy to answer. We have about 10 minutes while others join. I'm a little early, so just like all of you, let's get started. Cool. Good. Okay, good. It seems everything is working as expected. That's good to know. So we'll start the session itself at 7:03 or 7:04, something like that, right? Again, we'll do some simple Q&A at the beginning. We'll also do Q&A at the end. Don't worry about it. So this is a question from HeyCS. I believe it's an Elias. In September and August last week onwards, placements are going on. I'm doing good with C, data structures and algorithms, and not having good idea of Java. So that's okay. I mean, some companies might look for some object-oriented programming. So if you already know C programming, data structures, algorithms, picking up the basics of Java should be fairly simple. Or if you don't have time to pick up Java, just learn the object-oriented programming behind C++, because it builds on top of the foundations of C. So again, depends on the company, but most companies, especially at a fresh graduate level, they're looking for, do you know the concepts of basic object-oriented programming? And you can pick any language and use it as part of your interview process. Again, different companies might have different rules and languages that they prefer. But if you don't have time, just try and pick up the basic concept of object-oriented programming from C++ if you're constrained on time. Cool. So Abhijit says, I've just started my preparation. Can I get a good rank? Certainly. Of course, there are 2-3 major parameters. One is, this is late July, right? So you have August, September, October, November, December, Jan. So you have 6.5 months ahead of you. So make sure you're putting in 4 to 5 hours of effort. As I always say, 6 months is a good enough time. If you're serious about your preparation, if you're focused, 6 months is all you need to crack GATE. Of course, we have had students who crack it in 4 to 5 months, but realistically 6 months, even if you're an average student or a slightly below average student, if you're putting in dedicated 4 to 5 hours, again, maybe closer to 5 hours every day, you can comfortably crack GATE in 6 months. You just need to be disciplined. You have to work out all the problems. You have to practice a lot of problems. Of course, refresh your conceptual clarity through concepts and things like that. So if you go through the whole pipeline, 6 months, 4 to 5 hours for an average student is good enough to crack GATE. Cool. So Aniket is how to be consistent in GATE prep while campus placements are going on. My only suggestion is try and overlap your campus placements with GATE subjects that are useful in campus placements. For example, you can overlap things like data structures, algorithms, aptitude, even to some extent databases, because SQL is very popular in interviews. So try and cover these subjects in GATE prep during your placements so that it will be a preparation both for GATE and placements. Doing this simple moving around of subjects to cover them during your placement time, I think is a good opportunity to do well in both. Right? That's a simple strategy that works for a lot of students. Cool. Again, our team is also answering some questions. Is it possible? Okay, so how to revise completed subjects repeatedly? I think that's a very nice question. Suppose if you have already completed a subject, right? The first revision should happen as soon as you complete it. After you've completed a whole subject, revise all of the notes that we provide or the short notes that you've written. Take the subject tests. Again, if you're part of the course itself, you have both the 2020 and the 2021 test series. Please take the subject tests. If you have not taken the topic tests, also complete them. That's a great revision. Again, before you take the test, please revise all the concepts, take the test. That should be your first revision after you complete a subject. The next revision should come around 2 to 3 months after you finish a subject. Like every 3 months, all the subjects you have finished, please try and revise them again. That's a good time to take multi-subject tests. That's your second revision, right? So, I mean, it's a fairly clean method. Again, before you take any multi-subject tests, every 2 or 3 months, try to revise all the topics that you have already covered, all the subjects that you have covered, so that you can go ahead, take the multi-subject test. And once you finish the whole syllabus of all the subjects, then go for grand tests and all. There again, you will have a revision. So literally after you finish a subject, immediately after you finish, you have one revision, number one. Number two, you have it after 2 to 3 months. Then you have it after you complete all of the subjects, right? So at least 3 revisions you're going to do of the same subject. Again, the revision is you revise the concepts, take some tests, because revision through practice problems is one of the best strategies, especially for GATE. So again, somebody is asking how to stay motivated during GATE prep. How much ever motivation externally you get, it will not survive. Let's be realistic about it. You will feel high for a day or two and you will start studying, but after that it will all drain. All motivation has to be inherent. You have to be serious about your career, your opportunities, your learning process. Like I can motivate you for 10 minutes, 15 minutes today, and that probably will stay for a day or two, maybe 3 or 4 days, and after that it all goes down the hill. Motivation cannot be explicit or external. It has to be internal. You have to, again, the simplest way to fight that lack of motivation is to be disciplined. Make your habits, like what motivates you to wake up and brush your teeth in the morning? Nothing. It's just a habit that you have. So habits are a better model than motivation, especially external motivation, but internal motivation does help. So ask yourself what you want to be after you graduate, where do you want to study, what career opportunities do you want to have in the next 2 to 5 years. Again, those are what should motivate you internally. But so the worst is external motivation. Internal motivation is better than that. The best thing as compared to external or internal motivation is your habit forming methods. Make it a habit. Sit for 2 hours in the morning, 2 hours in the night, and don't get distracted. Study. I mean, that's the best way to make progress in GATE, right? I mean, that's the only strategy that I can think of. Cool. Namrata says, should I drop a year for GATE prep? Please don't. I mean, the simplest answer is please don't drop a year for GATE prep. We always recommend this, that if you're planning to drop, please don't do it for heaven's sake. If you have dropped, nothing can be done anyway. Just try to make the most out of it. Our recommendation is get into a job, whatever job it is. It could be a services job, product startup. It could be any job. Get into the job. GATE preparation can be done parallel to your jobs. So if you drop a year, and let's assume in the worst case, you don't get a good GATE rank that you would like to get, then that whole year is a career break for you. Again, getting job opportunities after that could become harder. So while there are some students who drop a year, sometimes even 2 years and succeed, there are also lots of other students who don't succeed, right? Because GATE has limited seats. That's a fundamental problem with GATE, right? Now, given that simple constraint, you have to, there is no other better way than not to drop a year, get into a job, prepare parallelly. That's the best strategy that we recommend. So Anurag says, till when should I aim to get placed and focus completely on GATE? Should I take up the first job I'm offered? Anurag, again, if you're prepared for placements, right, going and sitting in the placements is mostly a one-day work, right? There is a significant overlap of skills and concepts between both GATE and what you have for placements. So, try to get the best placement you can. Don't just get into something that is okay, because having a good backup option is always helpful. Again, as I told you, GATE has limited seats. It's only the first few hundred rankers. If you look at all the IITs, NITs, good triple ITs, etc., it's about 800 to maybe 1,000, first top 1,000 ranks. If you're not in that window, right, then You can take up the job, probably let's assume you get some 3000 rank or something like that. Go into a job, have a good job offer, get into the job, prepare the next year. Right? That's the best strategy that I can think of. I would do that if I were in those shoes. Cool. Why didn't you prepare for placements directly? Why did you choose GATE? I think that's a misconception. Suman is asking this question, which is, I actually had 3 job offers in my BTech, in my final year of placements. So in my BTech third year, I already had a good GATE rank, which was some 176 or so. And in spite of that, I still sat for placements. I had 3 job offers in my hand. Of course, I again wrote my GATE in my final year. I got a better rank. I got rank 2. And then I went into Indian Institute of Science. So even though I had a good GATE rank, I always had a backup plan. It's always good to have backup plans. I mean, that's a more risk mitigating approach than not having a backup plan. Okay, cool. So Somesh asks, please tell us the top 3 subjects as per vastness of syllabus. Again, it's relative, Somesh. The reason being, it depends on how you split subjects also. Like for example, whole of engineering math, right? You can split it by topics. You can say whole of predicate and propositional logic is one topic, right? Or one subject. It depends on how you split them. What is more important is how easy is it to score marks in each of these individual subjects. So we have a dedicated video on the order of subjects to prepare. Like we also have it on our website, gate.appliedroots.com. So we recommend you start with theory of computation and compiler design because it is very scoring. Then we say go with DLD because it's again, or digital logic design because it's very scoring. So we give you an order of subjects based on how easy is it to score, not necessarily how vast the syllabus is, because I mean, do you take whole data structures and algorithms as one subject or do you take them as 2 subjects? So it depends on how you split the subjects that the vastness or the length of each subject changes. Like I would actually group together TOC and CD logically because there is so much overlap of concepts between both. Cool. Okay, so we'll start the session in a minute. Just give me a second. So somebody says there are some mistakes in digital logic design tests. Just let us know because in practice tests, if there is an error, we would have most likely corrected it. But if you see an error, please email us. If there is an error on our site, we immediately correct it. I think this is about digital logic design tests. If there is an error, I mean, it's only human to make errors. So if there is an error, do let us know. We will immediately correct it. Okay. But we haven't gotten any significant feedback that there are too many errors. One person is saying this, it's an LES. Again, but if there is a problem, do let us know. Again, we encourage all forms of criticism because it always helps us to improve. Again, there is somebody who says about criticism. We appreciate constructive criticism, but we hate trolls. If you're a troll, we'll simply block you. It's as simple as that. So please participate in a constructive discussion. We are happy to hear you. Like somebody said, there are some problems in digital logic tests. Please let us know. We are happy to correct ourselves. We are humble enough to say that we have made a mistake and we will correct it. But if you just troll left and right, we will simply block you because there's no point in it. We hate trolls. We appreciate constructive criticism. Cool. So let's get started, folks. Okay, so here it is. Okay, so today's topic is, so everything is visible, right? Can you just confirm if the screen is clearly visible? Okay, I can see it myself. Okay, so let's get started. So today's session is a topic of propositional and predicate logic. Very interesting, very beautiful topic in whole of engineering and discrete math. This is the third live session, so let's get started. Let's start with some easy problems, then we'll go to more trickier ones. Please read the question carefully. Again, I'll take general questions at the end again. I'll answer the general questions later, but let's focus on solving the problems because that's what we are here for. Fairly simple question, like it's an MSQ. If you see this, it's written MSQ here. We're just warming up. So while we are solving the problems, please avoid general questions because we would not be able to entertain them now. I will surely spend some time at the end answering your questions. This is an easy question, typically like a 1-mark question. Again, not all questions from propositional predicate logic need to be tricky or anything like that. So that's why we have a mix of them today. Please read the question carefully. A good chunk of you got it right, but some of you have mistakes in your solution. Anyway, let's wait for a few more seconds for those people who made mistakes to correct. Okay, so let's get solving. This is a fairly simple problem. So you have two propositions P1 and P2, and it says which of the following are incorrect, and there are 4 options. So let's look at P1, right? So whenever I have a statement like this, whenever I have, let's say, A implies B, right? So I always change it to, okay, so there are multiple ways of writing it. Some people write it as not A or B. I write it as not A or B. So both of them mean the same thing. This also means not, right? So just, I mean, each of us have our own notational way of representing it. So this is easier for me. Again, it's just my preference. Different people might have different preferences. So let's write it as not P or Q or R, right? So that's what it is. So if A, then B is basically not A or B, right? Very simple logic here. So what is this equivalent to? So this is equivalent to this. Now what is this equivalent to? This is equivalent to not P or not Q or R. Now, is P1 a tautology? Think about it. Is P1 always a tautology? Tautology basically means always true. Need not be, right? For example, imagine if this is false and let's assume, sorry. There is an and here, I'm sorry. There has to be an and here, right? Because we are using De Morgan's law. So not P and not R. Right? So imagine if this is false and imagine if this is true and okay, so let's put it slightly differently. Imagine this is false, if this is false and if this is true, what happens now? Not true is false, right? So if P is true, Q is false, R is false, then what happens? What will this evaluate to? So not P becomes false, it is false and true, which is false. False or false will be false. So it's this expression which is equivalent to this, which is equivalent to this, is not always true, which means it's not a tautology, right? And the question says which of them are incorrect. So since this is incorrect, this option will be ticked here. Simple, first. Now let's go and do the same thing for P2. Is P2 a contradiction? Now again, same methodology. So not P or Q, sorry, not P or R, right? Not P or R, or not Q or R, right? Is this always a contradiction? Which means, is it going to be always false, or is there a possibility that it can be true also? So imagine if you have this. Imagine if just as an example, right? Imagine if this is true, right? Imagine if this is true, then not P or true, whatever this is, it doesn't matter, right? Because this whole thing will be true or whatever this is, it still be true. So this is not always false, which means it's not a contradiction. So this is incorrect, which means we will take this option. Now the next thing says P and Q are equivalent. They're not equivalent, right? Because if you think about it, what do you have here? Okay, let's just simplify this, right? Let's just simplify this. So P1 evaluates to this, right? P1 is equivalent to this. P2 will be equivalent to not P or R, right? Or R or not Q. Again, because R or R will be the same, right? I mean, you can just ignore that. So this is what it's going to be equivalent to. This is not same as this because there is an AND symbol here. This part is the same here, but between not P and not Q, there is an AND here while there is an OR here. So they're surely not the same. So P1 and P2 are not equivalent, which means this is correct and this is incorrect. And since the question says which of the following are incorrect, you have to take this, right? So while each of these statements are simple, this incorrect is what will trick up some of you. So some of you have chosen A, B, D, right? So it's always better to say, hey, the question is saying incorrect. So first let's say which of them are correct or incorrect, right? So we will not pick this because it is correct. It's just a small twist, right? This is a fairly easy 1 mark question by GATE standards. Very simple question. I mean, while I've taken a slightly lengthy path, this is very, very straightforward. We just have to be careful about incorrect here. That's it. It's as simple as that. Cool. Let me just see the comment section. Okay, no issues here. Cool. So let's go to the second question now, right? Okay, this is a very interesting question. This is the type of questions where students commit a lot of mistakes. This is about converting English statements to basically logic expressions. Please be careful with this. This is also an MSQ. Take your time, think about it very carefully. So somebody is asking, what does contradiction mean? It's the opposite of tautology. That's what a contradiction means. And if you don't know, I strongly recommend you revise the basic concepts of logic, because it's a very basic term in propositional logic. Good. I'm happy to see this. Again, this is a typically easy question, typically 1 mark question again, because the English sentence is not too complex, right? So it's a simple English sentence. It's one of the easier questions about predicate logic. I'm happy that some of you got it right, some of you messed it up here and there, but most of you got it right. That's what I'm happy about. Good. Again, since it's an MSQ, please see all the 4 options and try and understand them. Okay, many of you got it right. Very happy to see this. Good, good, good. Okay, so let's, again, this is the easier question for sure, right? So let's see this. Again, not all questions in GATE are hard. Like in propositional predicate logic, you might get one question that is slightly harder. Typically, rest of them will be easy, or I won't even say hard, I will say tricky and with medium level, right? So Rupert does not help anyone. And X belongs to set of people. Help basically means Rupert helps X. Now let's go through each of these. What does this mean? Okay, so let's see this. What does this mean? There is a not here. There exists. So not, right? There exists some X such that Rupert helps, so helps X, right? And there is a not in front of it. Now before you even do that, one more thing that you can see in these four options is that if you see A and D are equivalent, they're one and the same, right? Because if you have the not here, if you want to take the not inside, the there exists becomes for all. This is something that we have described and also derived in our course videos, right? So this is exactly like the De Morgan's law, but slightly different, that it's in the context of predicate logic, that if you want to take this not inside, this there exists becomes for all. Right? So if you see A is actually equivalent to D, they're basically saying the same thing. Similarly, if you see B and C, if you take the not inside, if you take this not inside, this for all becomes there exists and the not goes inside. So if you observe, B and C are one and the same, right? So that's the first observation. So the way I would look, because it's an MSQ, so I will first say B and C are the same, A and D are the same. Now, let's see which of them is easier to understand. If you think about it logically, right? I actually, again, different people have different perspectives in understanding this. I actually understand D much more easily than A. While they're equivalent, it is easier for me, at least logically, to understand it. Because what is it saying? It's saying for all humans, for all people, right? For all X, Rupert does not help X. This D is exactly same as this. And it's easier to understand D and translate that into English as compared to A. But mathematically speaking, using the De Morgan's law of predicate logic, you can show that D and A are one and the same. Which means since D exactly translates to this, and the question says which of them are correct translations, A and D have to be the right answers. Now let's go to B and C. They're still left, let's not forget them. They're slightly different from A and D. If D is correct, because D is very easy to map to this sentence, A obviously will be right. So very often in the real world, when you're solving, or in the examination, when you're solving problems like this, try and do this negation, try and move this negation using the De Morgan's law and see which of them, again, this is my personal opinion, that I do not understand this as easily as I understand this, right? And this are equivalent because I just applied the logic, the properties of predicate logic equivalence. Now similarly, if you look at these two, which of them is easier? Actually, for me, again, different people might have different opinions, but I see that C is easier to understand. What is C saying? C is saying there exists some person such that Rupert does not help this person. Look at this. What is it saying? There exists some person whom Rupert does not help. But that's not what it's saying. It's saying Rupert does not help anyone, right? So what C is saying is not exactly same as what is there in this sentence, because C is saying there exists at least one person, right? But here it's saying Rupert does not help anyone. So C is certainly not equivalent to this statement that you have, to this statement, and we know mathematically that C and B are the same. Since C cannot be equivalent to this statement, B also cannot be equivalent. Again, you could have started with B and shown that B is not equivalent to this statement, but I prefer C because it's easier to map that logic. So whenever you're given options like these with these negations, and so if you have negation, there exists something, right? Always, if this is hard for you to map it, the trick here in predicate logics and English translation is, if this is harder, just do it this way. For all X, not. So suppose if you have some statement, right? Some statement here, or some predicate here, not statement, sorry, some predicate, some P, right? Some P of X, right? You just map. If this is harder for you to get your head around, just use the De Morgan's law, and this might be easier to get around your head. That's what I often do when I have to do English to predicate logic and back. Okay, so the right answers here are A and D. It's just a simple strategy that often works well in practice. Okay, cool. So let's go to the third question now. I think I explained why not B, right, just a while ago, because I said, okay, so let me just go ahead. I showed you that, again, different people have different aptitudes of translating this. We know that C certainly is not equal to the statement, and we know that C equals to B, and hence B cannot be equal to the statement. It's as simple as that, right? That's why I asked you to use this trick. Again, it's very, very easy to get confused in these statements. This is a very, very valuable trick that will help you immensely. Given these two statements, oftentimes, again, we know that they are equivalent. Remember, through De Morgan's law, we have also proved this in the course videos that they're equivalent, right? The key thing here is sometimes this might be easier to map to a sentence. Sometimes this might be easier to map to a sentence. Pick one and play with it. That's an easier one. Otherwise, the chances that you'll get confused, for example, if I have to solve this problem with B, thinking with respect to B, or thinking with respect to A, the chances that I'll commit a mistake are very, very high. That's why this is a trick that I often use. Okay, cool. Sounds good. So it's for those of you who are saying why not B and C, let's see, let me just write B in English, right? So, so what does B mean? B says Rupert, so if I have to write B in English, right? One way of writing it is Rupert doesn't help everyone. Look at this, because there is every X, right? Rupert doesn't help everyone. If I have to translate B into English, because there is for all here, right? So that's why everyone, right? So this is one way to translate it. And this statement is not same as this statement if you think about it. Similarly, let's try to write C into statement, right? So C basically says there is someone that Rupert doesn't help. So there is someone, right? Because that's how you translate there exists. There is someone that Rupert doesn't help. Right? I mean, this is one way of translating, because English is a fairly complex language. This is one way of translating B and C, and obviously B and C are not correct. You can go through this path, but this path, when I go through this path, I make mistakes, to be honest with you. That's why I use this scheme. This trick is what I use often to avoid those silly mistakes on my part. It's a trick that I often use. Cool. Okay, let's get to the third question. Again, this is also a similar question. Again, please ask your general questions at the end. I'll surely answer them as many as possible. This is a slightly more complex sentence, but just think about it. It's straightforward. Again, if you're careful, this is an easy problem. These are typically of the gate type of easier questions that you tend to encounter. Good, good, good. Some of you got it incorrect, but most of you got it right. Just try to translate this sentence into predicate logic and then see which of them match that. That's the easiest way to think about this. This is actually an easy question, to be honest with you. Good, good, good. Many of you got it right. So let's dive into the solution itself. It's fairly simple. So Ramesh is either smart or honest, but Ramesh is not honest if he is smart. And here we are given this context that X be a person called Ramesh, and PX means X is smart, QX means X is honest. So let's try to translate it very easily, right? So Ramesh is either smart or honest. So which means PX or QX. This part is clear, right? One of these. Now you see this but. Now how do you translate this but into mathematical expression? Now let's see the second part. Ramesh is not honest if he is smart. Or in other words, I can rewrite this as if Ramesh is smart, he is not honest. And we can also write that in propositional logic very easily, right? How do we do that? If Ramesh is smart, PX, then if Ramesh is smart, then Ramesh is not honest. So not QX. Right? Simple. So this is also doable. These two parts are done. Now the confusion that some of you might have is, how do I translate this but? You can just replace this but. I mean, imagine if I put, you can just intuitively you can think and replace it by and. Right? But look at it this way. Imagine if somebody gave you these two sentences. If I replaced but with English and, right? There is no problem with it. The meaning of the sentence doesn't change. Ramesh is either smart or honest, and Ramesh is not honest if he is smart. Right? Makes the same, the meaning doesn't, again, if I replace this but with or, the meaning changes. But if I replace this but with and, the meaning doesn't change. Which means that my simplest argument here is, I just have to place an and between these two statements. Again, if you think logically, this is one statement, this is one statement, and there is a logical and. So in most cases like these, wherever you have a but, just replace it with and. It's as simple as that. Now, if you see, this is directly available to you as C, and this is an MCQ. This is not an MSQ. Now, if you see this is exactly same as C, right? It's a very simple question. This is a good, easy 1 mark question actually. While it might look complex on the surface, it's actually very, very simple, right? You don't even have to check for A, B or D here, because directly what you have gotten as an answer by translating this is as is present in C. This question could have been tricked a little. We could have made it slightly tricky by not giving this expression as is, but by evaluating this expression and giving some other expression that is equivalent to this. We could have given some other expression that is equivalent to this, or we could have converted into an MSQ with other expressions to make it slightly tricky for you, right? But we just wanted to keep it simple because objective is primarily how do you convert this compound statement into simple predicate logic statements, right? So it's as simple as that. Cool. So let's go to the next question. Again, somebody said that he cut a ticket and he did not get a reply. Can you please check your spam folder in email? Because some of these emails might go into spam folder, and if you still don't see it, just call us on the phone numbers. If there is a delay of more than 24 hours, we encourage you to call us on the phone number so that things are resolved ASAP. This is a good 2 mark question, so think about it carefully. This is an MSQ also, so please be careful. Don't be in a hurry, think through this, please. Please revisit your answers. This is a tricky question, to put it simply. Please revisit your answers. Please look at there exists and for all very carefully. Okay, I'll wait for some more time for some of you to correct your answers and then we'll go into the solution. This is slightly tricky, you have to be careful. Maybe there is an error in my answer, but anyway, let's solve it together. I see only a very few people getting it right, surprisingly. Maybe I made a mistake. Again, let's work it out. Okay, since we have had good time, so let's get to the solutions, right? P1 is a very simple statement. So for all A that belongs to a set of real numbers, this is there, right? So these are the two parts to it. So for all A that belongs to the set of real numbers, there exists a B that belongs to a set of integers such that AB is less than 10, right? That's what it is, right? So if I have to say, first you pick A, then you pick B, then you do this. That's a logical flow. So let's try to think about it, right? So what it's saying here is for all A, this should hold, right? So A can be any real number. There exists a B, right? So I need to pick just one B. Suppose imagine if I pick my B as 0, because 0 is an integer, right? 0 is a valid integer, right? So for all A, I can pick, because there exists B, right? So I can pick one integer 0. If I pick this, what happens? A into B, whatever your A is, A into B is going to be 0. Because any real number multiplied by 0 is 0. And this is strictly less than equal to 10, right? So this P1 is always true. It's always true because for all values of A, you can pick at least, there exists at least one B which satisfies this. So clearly P1 is true. Now the tricky part is with P2. So let's go into it, right? So let's try to break this. So this is what you have, logically speaking. So there exists a Y that belongs to a set of integers such that for all X, this statement is true, right? That's what we have to, that's what we have to validate, right? So what does this mean? This basically means, what does this mean? Okay, let's write this down. Let's take this part. This means that Y greater than 0 implies X equals to Y is a tautology, right? Is a tautology. That's what this means, right? That's what this arrow basically means, that this is always true. Now how do I translate this to, because this arrow mark is sometimes slightly confusing personally to me. So let me just modify it, right? So not Y greater than 0 or X equals to Y is always true. Again, this whole expression that is here, this expression is equivalent to this, which is equivalent to this. That's what it means, right? Let's think logically. What is written here is equivalent to this. What am I saying here? This implies this is always true, which means not of this or this is always true. Now comes the fun part. Okay, so it says there exists, you have to now, okay, this statement is there, but you have to take into account there exists Y and for all X. Okay, now let me do one thing, because I have to just pick one Y, right? Imagine if I pick a Y, that is less than equal to 0, some number, because it's a there exists, it's not a for all. Imagine if I pick Y equals to some -1, then what happens? My X can be anything, I don't care, because it says for all X that belongs to real numbers. right? If I pick a y that is less than equal to 0, then what happens? Okay, now for all x can be any real number, right? Because it says for all x. Now if y is less than equal to 0, what happens to this? This is always false. This is always false, right? Which means not false or x equals to y. I don't care whether this is true or false, because not false is already true. True or anything, I don't care what is here. True or anything is always true. You got the logic here, right? Because because what we have here is that there exists y, I can pick a y like this, y less than 0. Right? If I pick a y less than 0, then what happens? This whole thing, this part becomes true. If this becomes true, I don't care what is here. This could be true or false, but this whole statement will evaluate to true always for all values of x. For all values of x, it's true. So P2 is also true. This is a very neat flow of thought. So you have to work it out carefully, right? So if you think about it, P1 is true, P2 is true. Now what is the question saying? Which of the following is not correct? So let's see. P1 is true, P2 is false. Obviously this is not correct, so we tick this. P2 is true, P1 is false. This is also not true. Now what is this saying? This is saying, this is saying neither P1 nor P2 is false. One second. So it's saying neither, so P1, okay, one second. This is, neither nors are always confusing for me. So neither P1 is false nor P2. So both P1 and P2 are false. This is also untrue. So we tick this. Okay. So neither P1 nor P2 is false. Okay. Which means both. So this is equivalent to saying P1 equals to true and P2 equals to true. That's what this means, right? Neither this is false nor this is false, which means both of them are true. That's what this statement is equivalent to. And we know that this is true, which means we will not tick it. So the right answer is A, B and D. The right answer here is A, B and D, right? Many of you have said A, B, C, A, B, C, D, A, B, D, all of those things. That's why I told you at the very outset that this question is tricky. It's a good 2-mark question. And most of the cases, I believe many of you probably thought P2 is false by just looking at it without thinking through and breaking it down on the there exists and for all, right? So, no, somebody is saying a counter example. So let me go to that. Somebody is saying, hey, what if your y equals to 5? I don't care about this case. I really don't care, because this statement says there exists some y. I can pick any y of my choice. This is not true for all y. It's not for all y. It is there exists y, which means even if there is one such y, that's it. I'm done, because it's a there exists. It's not a for all. Lot of people probably read this as for all y, which is what it's not that. So for me to prove that it's a tautology, for me to prove that this whole thing is a tautology, I only care about one value of y, right? So simple logic. Again, this is confusing because P2 is intentionally confusing. There are two pieces of confusion here. Most of you probably thought P2 is false. That's one piece of confusion. The second piece of confusion is not correct. And these statements can be slightly confusing. Like neither nor, I'm always confused with that. Okay, so the right answer is A, B, D. This is a good 2 marks question. But you have to be careful when you apply for alls and there exists. For all, think, is there at least one such possible integer here that satisfies this whole thing? So the way to think about it is put this in parenthesis. Can I pick one y that will make sure that this is always true? Right? If you want to prove that it's a tautology, right? If you want to prove that it's a contradiction, you say, hey, can I pick at least one y where this is always false? For all values of x, it's going to be false, right? So that's the way to think about it. Cool. So sounds good. Let's go to the 5th question. This is a very nice question. Again, predicate logic is always confusing, to be honest with you. Yes, in our course videos, we mention, I think, at least 20-30 times that the order of quantifiers matter. And you have to take it seriously. This is a very nice question. Now, this question is also very interesting. Please be careful with this. It's an MSQ. Sorry, I forgot to put that. So it's an MSQ. Please be careful with this. Because you have, this should be true for any P. Those of you who know a couple of concepts from our course videos can easily solve this. But if you don't know, you're lost. We actually solve similar problems and derive some of these things from first principles in the course videos. And those are some of the best proofs I've done in discrete or engineering math. Good, good, good. I see many of you getting it right. I'm very happy about that. Cool, cool. This is one of the best proofs I've done in whole of the gates content, apart from probably undecidability, is related to this concept. Good, good, good. I see many of you getting it right. I'm happy you remember. So the hint for this, for those of you who are still trying to solve it, is there is something called as a one-way theorem. Right? We proved that in the course videos. So if you know the one-way theorem, this is like 1 minute question. This is typically a 2-mark question by gate standards. And this is often considered tricky or slightly on the medium level. If you don't know the one-way theorem, it's certainly tricky. But if you know it, it's straightforward. Cool. So let me solve it. So let's go step by step. Okay. So what it's saying, which of the following is correct? Because it's an MSQ, it's saying P1 is equivalent to P2, right? Which means P1 should imply P2 and P2 should imply P1. That's what it means, right? In this case, what does this mean? P1 is not equals to P2. So first let's solve for B and C. If both B and C are true, then A will be true, right? If at least one of them is not true, then D will be true. That's a simple logic, right? This is basic propositional logic. So with that, now let's look at what we have here. We have for all x, again, what is it saying? It's saying P1, so P1 implies P2, P2 implies P1, right? So if you think about it, what is the statement that you have here, right? So if you think logically, okay, so what does the one-way theorem say? One-way theorem says that imagine if you have an expression like this. Okay, so what does it say? If you have an expression like this, okay, again, we also talk about an octagon and things like that in the course videos, but what it literally means is this will imply, you can always take for all outside. You can't, so since you can take for all outside, this will imply, one second, so let me just, okay, so this will imply for all x, there exists y, pxy. So this is true. On the other hand, if you were to do the opposite, which means imagine if I have for all x there exists y pxy, right? I cannot take a there exists outside, and we discuss about this and we try to give the intuition behind it using nested loops in programming. That's the intuition that we provide, right, in the course videos. So if you try to pull this out, so this will not be equivalent to, sorry, or this will not derive. So from this you can't imply this. So this will not imply for all x p of x comma y. So now what you have here is you can't take there exists y out, but you can take for all x out, which means P2 implies P1 through the one-way through the simple concept called as a one-way theorem. This is what the one-way theorem basically says. So C is correct, B is surely not correct. Since B is incorrect, see both of them have to be correct for A to be correct, right? So the question says which of them are correct, right? So yes. So A cannot be correct now. Since P1 is not equivalent to P2, D is correct. Again, in the course videos, what we do is this, right? So whenever you have a statement like this, Pxy, right? So this is very, very helpful. Just in the interest of others who may not be course participants, I just wanted to explain this. So you have this octagon which says, hey, if you have, let's say, for all x for all y, right? For all x for all I will imply for all x for all y. You can do this, right? This will imply this. You can swap for alls in any way. But after this, you can replace for all with there exists. You can replace for all with there exists, right? And this will imply this. So you'll get a very nice shape of what will imply what. So from here, you can arrive at this by replacing for all with there exists, no problem. Next, through the one-way theorem, you can take this out, right? You can take this out. So you get for all x, there exists y. So if this is true, then this will also be true, right? Because of the one-way theorem. Now from here, I can again replace this for all with again there exists x, there exists y, right? Now there exists x, there exists y, because both of them are there exists. This will imply there exists y, there exists x. So here the order of these quantifiers, you can keep. So if you have this order is equal to this order, right? If you have this order, you can imply this. If you have this, you can imply this. If you have this, you can imply this. Both of these are equivalent. Similarly, you'll get an octagon like this, right? So for all can be replaced with there exists, right? Similarly, this for all can be taken out because of the one-way theorem, right? So you will also get this. Now this for all, is there something else? 1, 2, 3, yeah. So this is equivalent to this. So you get the shape of octagon, right? 1, 2, 3, yeah, I think 1, 2, 3, 4, 5, yeah, there are 8 nodes. So you get this shape. So you can go from any, this will imply this, this will imply this, this will imply this, this will not imply this. Okay, so this octagon-like shape is very, very helpful even if the question is slightly more complicated, right? If the question is slightly more complicated, you can still use this octagon-shaped methodology that we have described in the course videos and also derived the one-way theorem. Cool, I just wanted to discuss this for the benefit of those who may not be course enrolled students. And let's get to the general chat now. Cool. Again, I have my phone open. Just give me a second. I'll keep my phone open. Feel free to throw questions at me and I'll be happy to answer. Again, Sanjeev says, can you explain this with an example? For the last question, right, you can think of, let me just think of a quick example, right? You can take Pxy as x less than y. Just make, it'll work, right? But the problem in taking an example is, if you see the question, we clearly say it has to be true for all predicates, for all Pxy's. So you can't take an example because if somebody constructs a counter example to that, what happens? So it is better to do this from the strong foundations of mathematical theory and proving from there. That's what I would recommend personally. Cool. Yeah, for 3 variables, it will become slightly more complex. Again, 3 variable statements are very, very rare in Gate. We have not seen it to the best of our knowledge. But you can expand all the proof structure that we have done in the course videos. You can always expand it to 3 variables and k variables. That's something that logicians and mathematicians typically study, not very highly used in typical CS. Because if you think about it, right, the for alls and there exists can be translated into code, right? You can actually write it as a nested loop. Okay, that's the intuition behind for alls and there exists. That's a logical way of thinking about it. Wherever you have for all and there exists, the easiest way to translate these concepts and understand them is to write it as loops, right? There exists basically means you iterate through all the possibilities. Is there even one possibility? Is there one case where that is true? For all basically means it has to be true for all cases, right? That's the easiest way to think about it. Again, that's the logic that we also, that's the teaching methodology that we follow in the course also. So the previous year subject analysis videos, it's not discontinued. We will do it. Okay, just caught up in a lot of other things, especially with respect to surveys and other things. But we will surely do that. We'll update it for other subjects. We'll probably start focusing on engineering and discrete maths right away. We will do that. That's a good point. I mean, I think it just went behind our mind, but we'll do that. Thank you. Okay. So this is from Abhishek. I'm an ECE student. Should I start in 4th year for CSC GATE exam? Again, if you are an ECE student, I would personally recommend that you start your preparation early because you have a lot of new turf and new subjects to cover. It's better to start your preparation from 3rd year because you're competing with people who have studied the same subjects longer than you. So we typically recommend, I mean, the earlier the better. It's as simple as that. Because in your 4th year, you'll have project, you'll have your own placements, all of that which could interfere in your GATE prep. If you're a 3rd year student, start right away. That's better. So Pratik says, I've completed TOC, CD, DLD and C programming. Am I late? Not at all. I mean, it's okay. You have completed reasonable subjects. Just spend slightly more time. Since you have completed 3-4 subjects, you know how much effort it's taking for you to complete each subject. Just pace accordingly. Try to finish all the subjects by late November, early December, since you have completed already 3-4 subjects, right? So Pratik says, again, please point us to any mistakes. We'll happily update them. Again, some updates might take more time. But if it's a video or anything, we'll update them very quickly. So if you're a course enrolled student, one of the questions here is that you missed the previous live session. Again, the previous live session will be available in the recorded videos, in the corresponding flow of videos, right? So we will add it to that. You'll be able to find it. If there is any problem, do let us know. So this is from somebody who is a BSc student. If you're a BSc student, typically I think you require a 4-year undergraduate program or equivalent to appear for, to get admitted to MTech, right, at IITs or IISc or all the universities. So typical flow that we see for BSc students is either they do MSc or MCA and then they crack GATE and then they get into the MTech program, because typically BSc in India is a 3-year program, while you require a 4-year undergraduate degree for MTech at most universities. So Alpan says, I'm going to start my final revision before taking full-length tests. In this phase, I'm looking forward to thoroughly solve PYQs, practice tests and topic tests. Perfectly all right. Because if you're confident that you've completed all the subjects once, again, we wish you actually solved the practice tests in the actual flow of the topics. Any practice test or topic test or subject test that you have not done, please do it ASAP. And then please go, since you have time on your hand, please try and solve all the as many PYQs as possible, at least the last 5-6 years of PYQs, and then start the full length tests. Because you have completed early, you have more time on your hand, you should prioritize revision number 1 and solving as many problems as possible. So is GATE math for CSC required for competitive programming? Not much. Again, there might be some aptitude like questions. For example, how many graphs exists, permutations, combinations. That will help you in your logic building and thought process while you're solving competitive programming questions. But most of the graph theoretic questions that you encounter typically come from the graph algorithms and the graph data structures. Again, knowing discrete mathematics never hurts, but it is lower in the order of importance as compared to core data structures and algorithms. So Madhur says my rank is 5146. I think Madhur, in your case, the fundamental analysis that you have to do is which subjects are you lacking and which topics are you weak at. First focus on those, because the fact that you got a 5000 odd rank means that you already know some topics fairly well. Focus on those areas that you're not comfortable or that you think you're lacking. Start your practice and preparation with that strategy, and you already have an advantage that you prepared last year. So build on top of it, and it should be fairly easy to get into below 500 rank if you just put in that right effort at the right place. So somebody says full length test, subject test, topic tests versus, one second, so let me read this carefully. So full length test versus full length test followed by subject test followed by topic tests for weak topics versus topic test, subject tests, full length tests. So Harsh, we always recommend go with topic tests first, then subject tests, then multi-subject tests, then full tests. That's a better logical flow, because all the topics that you're weak, you will discover that quickly. Because all topics may not be thoroughly covered in a full length exam, right? Because you only have some 60 odd questions, right? You can't test everything in a full length test. You can't cover all the concepts. So it's better to start with topic tests so that you know where you're lacking. Subject tests, it's like going bottom up. It's better to go bottom up than top down, right? So start with topic tests, subject, multi-subject, grand tests or full length tests. That's better always. So is it okay if I don't give topic-wise tests of test series but give practice tests? That's okay, that's okay. First, practice tests are a must. You can always take topic tests during your monthly revision or a weekly revision type of stuff. That's okay. Practice tests are mandatory because they're designed to cover all the topics that you have studied just in that previous chunk of content. So somebody whose alias is Mad Max says, last time I prepared and my rank was 3100. Is it too late to start now? Not at all. You have a serious advantage. See, the fact that you already got a 3000 rank, again, the same strategy that I recommended somebody who got a 5000 odd rank, right? Look at your weak points, look at topics that you're lacking, and you can seriously improve your rank, right? Easily improve. But of course, you have to focus on areas and topics that you're lacking, practice more there, revise more, but don't completely skip topics where you're strong. Revise them, quickly solve problems, keep focusing on topics and subjects that you're weaker. So, I mean, without any, last year if you got 3100, you're not at all late. Come on. People could start their preparation this month or the next month and still get into the top 200 ranks and get comfortably. I think I've answered this question whether it's too late. No. 6 months, 4 to 5 hours a day. If you do that as an average student, you can crack GATE. IIIT Hyderabad versus old IITs, it depends on which old IIT you're talking about. IIIT Hyderabad is comparable in terms of the course curriculum, in terms of even the research work to some extent, and also in terms of their placements to IIT Bombay. So if you have to choose between, let's say, but of course, IITs have their own advantages and disadvantages. The biggest advantage is the fee is low compared to IIITs, but they're comparable in many fronts. So it's just a choice on what you prefer in terms of curriculum and areas of specialization. So is it good choice to give ONGC September for MTech or just focus on GATE? Again, if you have a PSU that is conducting exams and if you're preparing for GATE, and if PSUs are something that excite you and interest you, why not write the examination? Because it's mostly the same syllabus. There might be a few topics like general awareness type of stuff that might be different, but the core concepts and core topics mostly overlap with GATE. So if you're interested in PSUs, don't skip the exam, take it. There's nothing that you're losing by taking the examination. And whatever you're learning for that examination, 90% or at least 80% of it is useful for GATE also. Cool, I think I've answered most of these questions. Let me see. Again, I'm just going top down. Just let me look at it on my computer also. In case I missed something, I can scroll up here. Vijay says, how to get into top 100, damn sure. Nobody can give you that surety. If somebody gave you that surety, he's just fooling you. Let's be realistic about it. Okay. So I've seen some people who say, hey, you'll get a first rank or top 10 ranks. They're just foolish. They've never got into top 10 ranks and they don't know what it takes. It's random, to be honest with you. The difference between getting into top 10 ranks or top 20 ranks could be just a silly mistake on your examination. That's why I often tell you that I got lucky that I got GATE rank 2. Of course, I put in my effort, but the difference between rank 2 and rank 10 could just be 1 or 2 marks. In many instances, they are. So even top 100, there is no surety of it. Like you might prepare everything under the sun, but if you make silly mistakes in the last minute, then you might just push yourself into 150 or 160. But the difference between top 100 and top 200 is not significant. So you look at all the people who got into top 100 and people who got between 100 and 200, right, in the actual gate examination. In the long run, it really doesn't matter. Their outcomes in terms of career growth, in terms of learnings, hardly matter. So don't fixate yourself on the rank. Fixate yourself on the outcome that you'll go to a good university, study, specialize in some sub area and get into good careers. I think that's what you should focus. I think we are too fixated on ranks. Ranks sometimes, actually many times, like I often tell this to students that if the same gate examination is conducted again, there will be a lot of churn and there will be a different permutation of people in the top 300 ranks. I can just change the question paper slightly and the permutation of ranks in the top 300 will jumble up quite significantly, just depending on which topic got more marks, which topic got less marks, which topic got harder questions, and so on and so forth. So don't think about top 100 ranks. Think about getting yourself in a good 70 plus marks. Even if you miss the top 100, you will get 120, 130. Very good. And the strategy is simple. Solve more problems, revise concepts, avoid silly mistakes. It's as simple as that. But nobody can guarantee top 100 ranks. If somebody is doing it, they're just fooling you. Safe rank for getting AI at IISc. I think if you're in the top 100, you can comfortably get the AI program at IISc, or at least the MTech in computer science program, where you can again specialize in AI. Very nice question. This is by Sunidhya, who says, how long to struggle with one problem before looking at the solution? Every time I have solved it, but mess up in the end. Very nice point. Happens to all of us actually. So my suggestion, Sunidhya, is this. Tackle the problem the first time. Spend on an average, about 5 minutes. On an average, some problems might require 7 to 8 minutes, some problems slightly less. Tackle the problem. If you're not able to get to the solution, or if you've made a mistake, don't look at the solution, right? Just make a note that you've made a mistake there. Probably a couple of hours later, or if you're doing this in the morning, in the evening, or if you're doing this in the evening, the next day morning, re-tackle the question. Because you're making small mistakes at the end, right? Most likely you'll correct yourself. And those lessons and that problem solving skill will help you much more than seeing the answer. So at least give it 2 attempts before you see the answer. We would recommend 3 if you can, but 2 is the minimum, right? Because that way you're thinking what mistakes you've done the second time you're solving the problem. Give it that second attempt. If you still can't get it, it's okay, because we have like 7 months. See the solution, make a note of the mistake that you've made and work on it. That's the simplest strategy. But that's a good question. So Yash says, I'm a second year student, should I start now? Yash, my suggestion to you would be, please focus on becoming a good programmer, becoming good at programming languages that you have in your coursework, data structures and algorithms. Do some competitive programming. You can start your gate prep in your 3rd year, but having strong foundations in data structures, algorithms and programming will help you in a big way in the long term. So 2nd year, 1st year, I would recommend students to actually become good programmers, good in data structures, algorithms, do some competitive programming. From 3rd year onwards, you can specialize or prepare for gate and things like that. That's my recommendation. Of course, this might differ from person to person. This is at least my personal opinion. What are the odds that the syllabus will change? I'm no oracle. I don't know. But the probability, I think, is quite low, because GATE doesn't change syllabus every year. But I really wish GATE introduces programming questions from this year. I mean, I'm happy that IIIT Hyderabad did it, because it's a very fundamental skill for every computer science engineer. It's just that it's not easy to incorporate that into the GATE format. But I wish the GATE examiners have at least a couple of questions, of course, with more weightage of marks, ask you to write code for a given problem in any programming language of your choice. It could just be C also. I wish that is added, but I don't know. Most likely the probability that syllabus changes every year is quite low. We see syllabus changing only once every few years. The probability is low, but if the syllabus changes, it changes for everyone, and you're just competing with your peers. So don't worry about it as much. It's something that you don't have to worry too much, to be honest with you. again, there was a question that I saw earlier. So if you're a test series enrolled students, if you cut a ticket, we will only be able to entertain and resolve questions about the questions in the test series. We will not be able to answer questions outside the test series questions. I think we have also mentioned this very, very clearly when we were offering the test series. It is realistically impossible to answer every general question, because we did that to some extent last year. It was taking our energy and time of course enrolled students whom we have promised to resolve their questions as soon as possible and as thoroughly as possible. So if you're a test series enrolled student, please understand that we can only resolve your questions related to the questions in the test series. If there is any mistake, please do let us know. We will correct it immediately. And if you ask a question outside the test series questions, we may not be able to answer it. So somebody is asking about 15 to 20 years of PYQs, more than sufficient, folks. I mean, that's a very good chunk of questions, because 80 to 90% of questions in the actual GATE exam will be of the same formats as the last 10 years of PYQs, right? So don't worry about it, that's good. So one other question about query resolution. So whenever a student cuts a ticket, because we're going into the ticketing system because it helps us improve, measure, and quantitatively improve our system and our turnaround time and things like that. So when you cut a ticket, we will first try and provide an answer using text, because we can put pictures, we can give you more very specific answer to your question. In case that is not clear, right, we'll try and answer your follow-up questions also. In case it is not clear, we will set up a call and discuss over call in case it's not resolved. Okay. So, I mean, it's working fairly smoothly for us, no major issues, and things have worked fairly well for us. So I've enrolled for test series. Does one test series enough followed by PYQs? So in terms of practicing questions, if you solve our test series along with, let's say, last 10 years of PYQs, I think you're well covered. So more than sufficient preparation. Of course, how you solve the problems does matter. Don't look at the solution and think you have solved the question. No, you should be able to solve the question on your own, even if it takes 2 attempts or sometimes even 3 attempts. It is a problem solving aptitude that is important. To be honest with you, if you can solve 90% of the questions on your own, if not the first attempt, the second attempt, on your own without seeing the solution, either in a test series or 2021 test series, and even if you can solve like 80-90% of questions in the previous years, last 5 to 10 years, I think you're all set, right? You have a very high chance of getting a good rank in GATE. But again, solving doesn't mean seeing the answer. That's very, very important. Okay, cool. So yeah, I think I've answered most of the questions. Again, there are repetitions as usual. So see you next week, again the same time, same Tuesday. For all the course enrolled students, we will have another session on Friday. So see you on Friday for all course enrolled students. For the general public, see you on the coming Tuesday. Thank you very much. Thank you for your time. Bye-bye.